The future of humanity is going to be human intelligence amplified by AI systems that are at our service, essentially, and help us accomplish the tasks that we want.
Let me actually start with the imaginary elephant in the room. And the reason I call it imaginary is because I call that AGI. Sam Altman said that AGI is a few thousand days away. And you have a completely different view around where AI or AGI actually is. So would love to know that why is there such a diagrammatically opposite view between some of the top people? Some of them are your students actually.
Well, I don't think our views are that opposite. He says a few thousand days. So a few is not two, otherwise he would have said 2,000 days. So it's at least 3,000, right? And that's what, 8 years? Yeah, that's a reasonable estimate. I mean, what it means is that it's not next year, it's not 2 years from now. There's a reasonable expectation that we might have systems that kind of match human intelligence in most tasks within 6, 7, 8 years. The problem is that the probability distribution for this happening has a very long tail, and it's almost certainly harder than we think, because in AI, everything takes longer than we think. At least historically, that's been the case. So I don't think our views diverge. I think he's saying a few thousand days is different from what he was saying before. It's like, I mean, there were rumors, right? AGI reached internally, which nobody seriously believed, but it's that order of magnitude, I think.
And I know even Ray Kurzweil talks about the whole idea of singularity, and it's there and it's coming and it's come. How does all this add up?
I never believed in that concept of singularity. Clearly, things are progressing. There's nothing that looks more like an exponential than the beginning of a sigmoid. And every process, whether it's physical or societal, has some saturation, right? They all obey some sort of differential equation that has friction terms in it. So at some point, those friction terms take over and the exponential turns into a sigmoid. So I think it's true for any technological progress where you discover a new way to do things, and you make fast progress initially, and then you sort of maximize. Look at, I don't know, the speed of air transport, right? It went up from propeller airplanes to jet plane, and then it kind of saturated with an exception with the Concorde, and that was it. So I think it's the same with AI. We're not going to have like a fast takeoff. We're not going to have the mythical singularity. But what we're going to have is continuous progress, new paradigm. As one paradigm starts saturating, another one is going to take over, unless people who fund all of this research and development start losing patience, in which case people abandon the field and then we get a winter of AI. That's what's happened in the past, right? Multiple times. So I don't think it's going to happen this time, because there is so much demand, so much investment, so much of a business around it, that there's going to be continuous investment, but perhaps not the type of exuberance that we've heard about over the last year or so, of people talking about not just tens of billions of investment, but trillions. I mean, that sounds a little excessive to me.
Yep. And talking about the trillions, we are now all excited about the next wave of spatial AI, especially with, we are all addicted to our Meta glasses, whoever are using them. And Professor Fei-Fei Li just launched her own startup to focus on world models. So language models, which was largely text, numbers, images, and pixels, to us going through the three-dimensional spatial world. How does that change, and will the same frameworks of technology be able to do that?
Okay, so I've been trying to sell this concept of world models for at least 8 years. This was the main topic of my keynote at the NeurIPS conference in 2016.
$1 trillion opportunity.
It was, yeah, it was called NIPS at the time still. So the idea that somehow, if you want a system that can approach anywhere near not just human intelligence, but even animal intelligence. We need AI systems that understand the physical world, have persistent memory, that can reason and can plan. And if you want a system that can plan, it needs to have a mental model of the world that allows it to predict in advance what the outcome of a sequence of actions is going to cause. So that's what we do when we plan. We imagine taking an action or a sequence of actions, and then we imagine the result, and then we can optimize that sequence of actions so that the result satisfies an objective. Okay, so this kind of architecture, completely different from LLMs. LLMs are not like this at all, right? They don't plan, they don't reason. They appear to be doing this, but really they're retrieving their training data.
They're called the next word predictors.
Well, the next word predictor, which is surprisingly powerful, so you don't want to reduce what they're doing to just, matrix multiplication and next word prediction. I mean, they do something that's sophisticated, there's no question about it, but it's still very much akin to what psychologists call system one. So the kind of tasks that humans do without thinking, subconscious processes where you just react to something, but you don't actually plan or think about it. But the essence of intelligence is the ability to solve new problems you were never faced before without having to learn. In machine learning, that's called zero shot. And that kind of ability requires an ability to search for a solution to a problem. You're faced with a problem, and many of you are students. You're given problems that you need to solve. You may not have a template for how to solve that problem, so you think about it hard. It might take longer to solve harder problems, right? And then, among all the possible solutions, you find one. That process is internal to your mind, to your mental model of the world. And I'm talking about a problem in physics or engineering or mathematics, but it's true also for everyday problems. You're planning to build something. It doesn't have to be very complicated. You need to plan. You need to have a mental model of what your actions will result in. And this is not specific to humans. Cats and dogs can do pretty complex hierarchical planning that we're completely incapable of doing today with AI systems. So those four characteristics of intelligent behavior, understanding the physical world, having persistent memory, being capable of planning and reasoning hinge on the concept of world model. What is a world model? If you have some idea of the state of the world at time t, and some idea of an action or a set of actions you might take, your world model will predict the state of the world at time t+1 after you take those actions. Okay, if you have such a model, then you can imagine the outcome of a sequence of actions. You can check whether this sequence of action will satisfy a task that you want to accomplish. And what you can do is something very important that LLMs don't do, inference through optimization, which means searching among the set of possible sequences of actions for one that actually satisfies the objective. And you do this in your mind. That's how we do planning. This is actually a very classical approach to planning in optimal control. It's called model predictive control. It's been around with us since the early 60s, basically. So that concept is not new. The concept that is new is the fact that those world models can be learned from data. We can do this with deep learning now. So that's the future, I think, of AI.
I can only imagine the compute power needed to do this, right? Yeah, it's crazy.
Well, I mean, of course, if some very big amount of compute power is made available, it's going to be used. There's no question. Nature abhors a vacuum, and computer scientists abhor empty memory. So, yeah, no question. But it's not just a matter of scale. So the idea somehow that some people have been advocating after the emergence and success and popularity of LLM, the idea that you're just going to need to train those systems with more data and train bigger models, and we're going to reach AGI or whatever you want to call it. We don't call it AGI at Meta. We call it AMI, Advanced Machine Intelligence. We actually pronounce it AMI, because that means friend in French. And there's a lot of French people at Meta, at FAIR. So we're not going to reach that stage by just using the current paradigm and just making it bigger. We need essentially new architectures of the type that I just mentioned that are called objective-driven architectures.
I love your concept of world models, Jan. I use it often to explain to people why people from IIT are running the world in things that are not necessarily engineering, because we're really good. Our JEE exam is really good at testing people for being able to create those world models. But pushing the boundaries of artificial intelligence to reach human intelligence always comes with questions of safety. And for a long time, I think a lot of us wish we could be a fly on the wall when you and Geoffrey Hinton are having discussions about this, where he's saying, I think that I'm going to dedicate the rest of my life to working on AI safety and not pushing the boundaries of artificial intelligence, and you continue to push those boundaries to create. How does that conversation go? Do you converge at one point and then begin to diverge?
Okay, Jeff and I are old friends. We've known each other since 1985, okay, almost 40 years, and we agree on many things. We certainly agreed for 40 years of the approach of training neural nets to reach, to make machines more intelligent. The fact that, we don't really manipulate symbols in the way that sort of classical AI envisioned it. We more manipulate sort of continuous concepts, and this idea of world model, he certainly agrees with this kind of stuff. But then we've disagreed in the past on technical issues. For a few of them, I was right. For a few of them, I was wrong. So, for example, he was an early proponent of what he called unsupervised learning, which we now call self-supervised learning. And I was really skeptical initially when I was a postdoc with him in the 1980s. I rallied to his side in the late 90s when I realized really this was the way to move forward. And then there is some more technical issues where we disagreed, and he eventually rallied to my side. So he really didn't like the idea of stochastic gradient when I was working with him in Toronto. And I said, that's the only way to go, because that's the only way the optimization algorithm can take advantage of redundancy in the samples. And he thought that was just wrong. And I knew he was right, and I was right. So, I mean, everybody uses SGD now, right? Stochastic gradient. So, and then there were other things that we had. So I came up with a concept called Siamese networks back in the early 90s, and he had a paper a few years ago called SimClear, where they kind of reused the concept for learning, basically unsupervised learning of image features. So this is the kind of stuff where we've gone back and forth. But on the question of whether intelligent machines will be intrinsically dangerous, we just disagree. And we just disagree. There is another question which I think is a little more fundamental. So he said that he thinks LLMs have subjective experience. Okay? And I completely disagree. I don't think LLMs, autoregressive LLMs, have the required architectural component for things that we could identify as subjective experience. For that, you need to be able to anticipate. You need a system that's capable of saying, okay, this situation looks dangerous. Like if I don't do the right thing, bad things are going to happen to me or others, right? So elation, fear, things like that are the result of our ability to anticipate what's going to happen. And so that requires those world models that I was talking about earlier. And LLMs just don't have one. So they cannot possibly have subjective experience. Now, I think where he comes from psychologically is that he's 77 years old, and he just decided to retire. And a good way to retire is to just declare victory. You say, okay, no, it's true. His quest of his career was to discover the learning algorithm of the cortex. And what he realized with LLMs is that perhaps whatever the cortex uses is actually less efficient than backpropagation. And you say, well, maybe if you want the brain to implement backpropagation, you need to have like a whole circuit of 10 or 20 neurons kind of, computing all the signals that are necessary for this. And so the equivalent of a simulated neuron in our artificial neural net would be a clump of 10 or 15 neurons. And the human cortex has about 16 billion neurons. So divide this by 15 or 16. And what that means is that the human cortex is the equivalent of a 1 billion neuron neural net. And we're not that far from a system of that size. So you say, oh my God, we've reached human intelligence, right? And and so I can declare victory, I can retire, but wait, those systems are going to be smart. So the other thing that we disagree on is the whole idea that intelligent systems necessarily dominate less intelligent ones. He's made that statement, and I completely disagree with this. It's not even true within the human species. It is rarely the smartest among us that want to be the chief, right? I mean, we have examples on the international political scene every day. And the future of AI, in my opinion, is a future in which everybody will be walking around with smart glasses or assistants basically that will host AI assistant that will help us in our daily lives. It would be like walking around with a staff of really smart people working for you. Okay? Those systems are not going to want to dominate us. They're going to do our bidding. We're going to tell them, we're going to give them problems, they're going to solve them for us. We're going to give them tasks that they're going to accomplish for us. But they're not going to come up with their own idea of what they should do, right? That's what you need if there's any inkling of domination. Why do some humans want to dominate other humans? It's because we're a social species, and our organization is a little more sophisticated than baboons, but not much. So, or the cute little monkeys that we found on campus here. They have a social organization, and in human societies, you can acquire status in two ways, either by domination or by prestige. Now, we are academics. We go for prestige, okay? Some politicians also go for prestige. Others, not so much, it's domination. But if you're a politician, you're very accustomed to the idea of being accompanied by a staff of smart people who are almost certainly much smarter than you are. We should not feel threatened by this, we should feel empowered, okay? The future of humanity is going to be human intelligence amplified by AI systems that are at our service, essentially, and help us accomplish the tasks that we want. There's not going to be any desire of domination because that doesn't come with intelligence. It comes with testosterone. And we're not going to hardwire any kind of drive for domination into our AI assistants, right?
So new prompt is, hey Meta, help me win elections.
I love it. Objective-driven human beings, I think, as much as...
We are objective-driven, but one advantage of those objective-driven architectures is that they're not going to be able to escape their objectives. And some of those objectives are task objectives, but other objectives would be guardrails. So you're talking about safety. This is the way to build a system so that you can guarantee safety. You hardwire some guardrails, and at runtime, the system, when it figures out what output to produce, has to satisfy those guardrails. They will be like constraints in an optimization process, if you want, okay? So in that sense, those architectures would be safer than the current ones. LLMs are, some of my colleagues who work on Llama don't like me saying this, and Mark Zuckerberg doesn't like me saying this either, but LLMs are intrinsically unsafe, okay? Doesn't matter because they're not really smart, so they're not going to kill us, but in effect, they have a bit of a flaw that we're hoping to fix within the next few years.
I think the safety of LLMs actually is the question that I have next around the thought process behind open source, which I know you believe makes things more safe, but potentially when you hardwire these guardrails, it also opens up people to take out those guardrails. So how do you balance these two?
I mean, there is really interesting and serious questions to discuss about, the fact that AI is a powerful technology, will become an even more powerful technology, and when you put powerful technology in the hands of people, good things will happen, but also bad things may happen. And so I think people have been overreacting a little bit to that. I remember back in the old days when OpenAI produced GPT-2, they did not open source it right away because they say, this thing can generate text and it might flood the world with disinformation and destroy democracy. And I trolled them because I thought that was a ridiculous argument. I mean, those systems are not that smart. So they ended up actually open sourcing GPT-2. And then when, we open sourced some LLMs on the way, they did not open source GPT-3, so we built one that we called OPT, which was basically identical but open source. And the world didn't end. And here's another interesting story. At the end of 2022, we produced an LLM. Some of our colleagues at FAIR produced an LLM called Galactica. Some of you may remember what that was. It was trained on the entire scientific literature, and it was a prototype system that was designed to help scientists or students write technical papers. In LaTeX, for those of you who know what that is, right? Most of you, I'm sure. So, very useful. We were talking to Overleaf and other companies to kind of provide this as a co-pilot for people writing papers. So we put the demo, the paper, and the code on the web, and we were doused with a deluge of insults and vitriol. Basically, people saying, this is going to destroy the scientific publication system, the world is going to end because you can ask the system to write a paper on the benefits of eating crushed glass. And so now those papers are going to sound authoritative and people are going to eat crushed glass and die. I mean, how stupid can you be? But, so I, counteracted and said, no, I mean, that's a ridiculous argument. Sure, I mean, you can do stupid things. You ask stupid things to a system, it's going to accomplish your stupid task. Just don't ask it stupid things. But it was, bad publicity for Meta. And the poor small team of 5 people who had built the system didn't sleep at night. So they took down the demo. They kept the paper and the code, but they took down the demo. And as a result, something that could have been useful disappeared from the world. 3 weeks later, ChatGPT was released. And this was the second coming of the Messiah. And all of us were like, what? What just happened? All of a sudden, now it's the best thing ever. 3 weeks ago, it was going to destroy humanity. And so this was a big surprise. And it was a big surprise for OpenAI too, by the way. They were really surprised by how popular that system, by the enthusiasm of the public for it. But that basically prompted people in the AI R&D business to realize, right, there is a market for it now. We need to have product organizations that actually make real things. And at the same time, as it turns out, there was an internal project at the end of 2022. There was an internal project at FAIR in Paris called Genesis. And that project was a fairly compact LLM that turned out to work really well. That became Llama. Llama 1. That was released for researchers. I'm sure some people at IIT Delhi downloaded it and experimented with it. But you had to apply for it, show that you were a researcher. And we got so much enthusiasm for the system that for the next release, Llama 2, there were lots and lots of internal discussions at Meta, including, Mark Zuckerberg and 40 people down from Mark Zuckerberg, debating as to whether we should open source and how we should open source and whether the benefits outweigh the risks. And at some point, Mark decided that we should do it. And we released Llama 2, and the impact was enormous, and with Llama 3 even more enormous. And again, the world didn't end. In fact, a new world started, including in India. I've been talking with a lot of people from the startup world, the research community, from big companies. I was at Infosys yesterday at the headquarters. And people are telling us what they're doing with Llama 3. It's just astounding how many projects there are, how many things are being deployed. And the usage is really taking off. And so I think a lot of the fears have been just completely overblown, and the benefits far outweigh the fears. Now, the second thing, which is important, is that what we found at Meta is that the best protection against misusage of AI is better AI. So you might think that, social networks would be flooded by disinformation that is automatically generated by AI system. This was a fear that some people actually expressed. we're not seeing this. Like, there doesn't seem to be a lot of, a flood of disinformation that's AI generated. But the countermeasure that we have uses AI. So it's AI systems that detect, whether it's like a single source that produces disinformation automatically, or whether the statistics represent a particular LLM that we know about, or whether the content, is obviously dangerous or whatever, or hate speech or something like this, right? And we use incredibly sophisticated AI systems for things like hate speech detection and terrorist propaganda and, child exploitation and things like this, right? That's where probably some of the most sophisticated AI systems are used within Meta products.
So today is a very exciting day. NVIDIA CEO Jensen is in Mumbai, and he appeared with Bollywood superstar Akshay Kumar and Mukesh Ambani, and talked about how Bollywood, entertainment, media, healthcare, every industry is going to get completely reimagined. So how do you think India should position itself to take the maximum advantage of this opportunity? Given I know that NVIDIA and Meta are working very closely, you announced that partnership. So how does that impact the world, and how can we take advantage of it?
Yeah, the partnership with NVIDIA actually is quite old, because when we started FAIR 11 years ago, the first thing we did was talk to NVIDIA and give them code for implementing convolutional nets, because they didn't have a good infrastructure for this, and they derived what became cuDNN basically with that. So we've been kind of working with them in some way for quite a long time. What's happened in recent years and months is that there's been a lot of GPUs going one way and a lot of dollars going the other way. And a lot of information. So, for example, one of the best LLM is slightly specialized, but one of the best LLMs that now on the market on a really relatively compact form is from NVIDIA. They released it last week, I think, and is built on top of Llama 3.1. So they are very enthusiastic about the whole idea of open source. What they are seeing, also what we are seeing, is that a lot of people use the open source llamas and try to kind of optimize them so they can run on very simple computing devices, laptops, but eventually smartphones and embedded devices. In fact, our colleagues just released Llama 3.2 with, which is one of them is a 1 billion parameter system that you can quantize down and practically run on smartphones. So, I mean, there's going to be a huge amount of progress there, and the hardware industry is really working towards improving the efficiency, not just of training, which is currently dominated by NVIDIA, but also of inference. And I think making progress in inference, both from the software and hardware side, is very important, particularly for India, because there's going to be a future not too far from now, where the smart glasses are going to be cheap enough that a lot of people, as many people will have them as have smartphones today. So that includes, farmers or people in rural areas, many of whom speak the local dialect, maybe don't write very well, are not familiar with technology. They can just talk to an AI assistant in their own language. So we have a collaboration, for example, with various institutions in India, so that the next generation of Llama will at least speak the 22 official languages of India, okay? Now, that's a far cry from the 700 languages and dialects that are spoken in India, obviously, but it covers, maybe 90% of the population. Now, eventually, we want those systems to speak all 700 languages so that people can preserve their culture, can converse in their own language. So we'll have smart glasses that can do simultaneous translation. That's coming pretty soon. Eventually, those glasses will have displays. And so you'll get subtitles whenever someone speaks to you in a language you don't understand. And what we have is technology that we've demonstrated that can do translation of languages that are not written, purely spoken languages that don't have a script. That's super important for this kind of application. Okay, now there's 700 languages in India. There's another 700 in Indonesia. There's 1,400, I'm told, something of that order of magnitude in Africa. You know, it's not going to be an easy task, but that leads to a very important point, which is that I don't think any single entity or any single company in the future will be able to train a universal AI foundation model that speaks all languages. It's just not going to be possible. The cost, the access to data, the local expertise in local languages that is required is just not going to be present or available to a single company in Silicon Valley or in Beijing, right? And so whatever the future of AI is, the training of the big models is going to have to be distributed. India has a very important role to play there because of the strength of institutions like yours, but also, you know, because of the size of the population, the diversity of cultures and languages and value systems. So I think that's kind of crucial. That's the future I'm envisioning. And this is enabled by open source collaborative platforms. And it will lead to a future where, you know, we may have foundation models that speak all the languages in the world that basically constitute more or less the repository of all human knowledge. But then, because it would be open source, people would be empowered to specialize those systems for, you know, a particular cultural interest or biases or value systems. And that's very important because eventually all of our digital diet will be mediated by those AI assistants, and we don't want them to come from just 2 companies on the west coast of the US. We need them to be very diverse. For the same reason, we need a diverse press, right? That's a precondition to democracy, right? Same with AI.
Lovely. We have, in the spirit of democracy, we have a number of student questions. And if the students who've sent these questions in advance, and if they're here, I'll just read their name out, and if they can stand up. We had Abhishek Kumar of IIT Delhi asking what areas of AI research are currently unexplored and hold a lot of promise for the future. Where would you direct their attention? Okay,
one of my favorite topics. Okay, you are thinking of starting graduate studies in AI or doing a PhD, or maybe you have started a PhD or a master's in AI, or maybe another graduate program because you have programs now in AI here. Do not work on LLMs. All right? I mean, you need to know about LLMs, you need to know about transformers, you need to know about autoregressive prediction, you need to know about some of those tricks, but just don't do research on it, because you'd be in competition with enormous teams of hundreds of engineers, a number of them alumni of IIT, with enormous amounts of computing resources. And it's just not worth it. You know, I mean, there were similar situations in the past in, let's say, speech recognition. It was completely pointless to work on speech recognition in the 2000s if you didn't work at Google, IBM, Microsoft, BBNN, and a couple others, because you just didn't have the infrastructure for it. Okay, but what you can do is come up with new ideas. Okay, you don't have to demonstrate them on like enormous data sets with, you know, that will require thousands of GPUs anyway, but just new ideas, new concepts. They mostly come from academia. You know, for example, the whole idea of attention. Attention is all you need, right? Famous paper. That basically was the idea of the transformer architecture. The basic idea of attention came from University of Montreal, a paper by Dimitri Badanao, Kyung-Young Cho, who is a colleague at NYU now, and Yosha Benjo. And they used it to build a prototype translation system. They showed that you could translate from one language to another with reasonable performance. They weren't beating any record. It was reasonably good. A few months later, Chris Manning's group at Stanford re-implemented that idea and actually won one of the WMT competition, the translation competition that takes place every year, at least for one pair of languages. All of a sudden, everybody was paying attention to translation and to attention circuits, and this is what prompted, you know, Google to come up with this transformer architecture. But what Yoshua told his lab after 2015, he said, stop working on translation. There's no point. It's now in the hands of industry. They're going to take it and run with it. And like, there's nothing we can bring to the table anymore. We gave the original idea, that's it. So, same thing. So let me tell you a few problems that are completely unsolved. I talked earlier about the idea of planning, particularly hierarchical planning, right? Let's say, we do this all the time, right? We even do this for a very simple task like filling up a glass or things like this. We actually plan this kind of stuff. But let's say there is a more complex situation. I'm sitting in my office at NYU. It's the afternoon. I want to be in Paris the next morning, okay? I cannot plan, like, if I were to plan this at a single level, I would have to plan my entire trip in terms of action I can take. But low-level actions for a human is muscle control, like forces you apply to your muscles. Every millisecond you change it, right? I cannot plan a trip from New York to Paris in terms of millisecond by millisecond muscle control. That's impossible. Because you just don't have the information, and it would be too complicated anyway. So we do this hierarchically. We say, okay, I want to be in Paris tomorrow. First thing I need to do is go to the airport, catch a plane. Okay, now I have a sub-goal going to the airport. Okay? I can figure out a sequence of actions to be near the airport. I'm in New York, so go down in the street, call a taxi, hail a taxi. How do I go down in the street? I have to go to the elevator, push the button, and then walk out the building. How do I go out to the elevator? I have to stand up from my chair, pick up my bag, open the door, go to the elevator. And now I can't, below this, I can't describe it anymore because it's in terms of things that are not expressed in language. And that puts the finger on the big question of how do we get machines to understand how the world works so that they can understand this foundation. Their intelligence is grounded in reality and is not just built with language. There is a calculation that you might have heard me say before. A big LLM is typically trained on 20 trillion tokens. 2, 10 to the 13, right? A token is typically 3 bytes. So that's 6, 10 to the 13. Let's round this up to 10 to the 14, okay? 10 to the 14 bytes to train an LLM. The text that those tokens are derived from is maybe the entirety of all the text publicly available on the internet. It would take any of us several 100,000 years to read through it. Enormous amounts of information. Now, a 4-year-old has been awake a total of 16,000 hours, at least that's what psychologists tell us. In 16,000 hours, the amount of information that goes from the retina to the brain, every second is about 2 megabytes, because we have 2 million optic nerve fibers, and each carries about 1 byte per second. So do the arithmetics, and the total amount of information that a 4-year-old has seen through vision is about 10 to the 14 bytes. It's about the same. Okay? That tells you that we're not going to reach human-level intelligence by just training on text. It's just not happening. We need systems to understand the real world. And the bad news is that the current architectures of autoregressive prediction does not work for video, does not work for images. We need other architecture. The one I've proposed is called JEPA, that means Joint Embedding Predictive Architecture. You can read the papers, listen to technical talks about this. I'm sure some of you already have. I'm very excited about it, and we're working towards that.